Sorry about that, guys. I totally looked down and didn't see what I wanted in my notes, and I totally got lost for just a second. And so I just pushed pause and the thing stopped. So now we have 2 videos. Sorry about that. But don't worry. I know I already talked for about 30 minutes, so we're almost done with this. It's going to be okay. All right. So anyway, what I wanted to say is I need this thing here to equal a 9, right? So what I'm going to do is I'm going to take this guy out. I know that what I did here up at the top is I multiplied the 30 by here, and I multiplied the 30 by here, but I didn't multiply whatever this fraction guy was by 30, right? Okay, so, yes. So what I'm going to do is I'm going to say, hey, I know I want this guy to be a 9, this total. So it's going to be 30 times that stuff. That's where we were. I don't want it to be 30. I want it to equal to the 9 that I want to add in, right? Okay. So whenever I, for lack of a better word, distribute that 30 through, well, that is the better word. Okay. So I distribute that 30 through and I get to that thing. Whatever this is, I need some fraction here, or fractions. Okay. That I can look at that and I say, what in the world can I do to that to make it equal a 9? Okay, so again, I'm going to have to play with it just a little bit because I want to pick wisely my fractions, right? And I'm multiplying by 30 here, so these things need to add up and equal 9. So what in the world could I multiply by that would get me to the 9? That's what I'm after. So I'm thinking, okay, I need some stuff that will add up to 9. And I need to think about how I'll get there using a 30. Okay. So for instance, if I use 4 here, 30 times 1/4 to pick, I don't want to do that, right? Because 30 over 4 doesn't reduce out nicely. That's going to be 15 over 2, and that's ugly, and we know that's not a fraction that they're going to use. So that we don't want that, right? We want something that's going to be a nice, pretty whole number. So in my head, I'm saying, well, what are things that go into 30? Because we use 30 because it was a nice, pretty common denominator up there, right? Between the 3 and the 30. So don't do something that's not going to divide 30 evenly. That's ugly, right? So do something that will divide 30 evenly. So maybe we'd pick a half. Maybe we'd pick, well, can I pick a half? Let's talk about that for a second. Can I pick a half here? I'm already adding 2/3 and 1/30 and some other fraction, and I want to get to a 1. 2/3 plus 1/2, if I put a half in there, will put me over a 1, right? So I can't do that guy. So I don't want to multiply by a half. I could multiply by a 1/3. Let's talk about that. 30 times a 1/3. It's getting me closer to what I want, right? Could multiply by a 1/3. A 30 times a 1/3 would be a 10. That's not exactly what I want, right? I wanted a 9, so not quite. It's a little too big still. So because it's too big, I don't want that, so I'm not going to do that. So I'm like, okay, I already said I don't want 1/4. That's an ugly number. What else divides 30? 1/5, right? So 1/5 divides it. Let me get rid of my don't do this. That's the bad numbers I didn't want to pick. So what do I want to pick, right? So again, and you're trying to be as smart as possible about this. Trying to pick nice numbers. Well, 30 times 1/5, it's not going to quite get me to 9, but it's going to give me a really nice number. That's 1/6, or that's going to be 6, right? Okay, so 6 is less than 9, first of all, so that means I can use it. I'm not going over, okay? And 6 is a nice, pretty number. I can put that in here. So 1/5 is one of the things. So now I'm not quite to the 9. What do I need? I need a 6 plus a 3, right? To get me to the 9. In my brain, I'm hearing you say 3. Okay, I need a 6 plus a 3 to get me to the 9. So the question is, how can I get that? 30 times what fraction? 1/10, right? So if I did 30 times 1/10. So I think if you can get one of them going, that the other one will kind of fall out, and that'll make sense for you. So here what we've got is, and let's see if it'll work. Hopefully our guessing, it's really kind of a smart, educated guess is what we're after. So I'm going to scoot this up a little bit. Hopefully that works. So here's what I've got. Let's distribute it out. 30 times 1/5 plus 30 times 1/10 equals 9. That's what I've got. So 30 times 1/5 is 6. 30 times 1/10 is 3. Sure enough, that equals 9. Okay. So let's go back up to our original problem, shall we? It wasn't. To our original problem. Here we are. We've got, let me do this. 2/3. Well, it's not quite the original problem. It's a little bit beyond the original problem. 30 times 2/3 plus 1/30 plus some stuff. What was the stuff? We just got it. The stuff was 1/5 and 1/10, right? Okay, so I'm going to put that in there. So the point being, I just picked 30. 30 didn't even matter. 30 wasn't even a point. We didn't care about 30. But if it'll work here, it'll work whenever I divide everything by 30. So here we go. 30 times 2/3. We already did that once. That was 20. 30 times 1/30. That was 1. I just did 30 times 1/5. That's 6. 30 times 1/10. That's 3. And when I add all this up, 20 plus 1 plus 6 plus 3 better give me the 30. Okay? So we think we're okay. Let's look at the rest of it. The original was, I didn't care about 30. So what we want to know is, does this equal a 1? Right? That was the original problem. So going way back here to the original problem. I just picked that in. It didn't matter at all. Okay, so I go way back up here to this problem, and I look at it, and I say, well, for us, we would probably get common denominators, right? So this is 20 over 30 plus 1 over 30. And look what's going to happen here. This is interesting. Because I used 30 for my number that I multiplied by, it's actually, here I'm going to multiply by 6, right? So 6 over 30. Here I'm going to multiply by 3, so 3 over 30. And that's going to equal to 1. Because what's actually happening is I'm getting the 20 and the 1 and the 6 and the 3. They're all on the top. Look. Oh, where did it go? Sorry. Yeah. So right there I had it, right? Well, oh, it's right here. I'm sorry. 20 plus 1 plus 6 plus 3. There it is. I have it there. And I'm getting those same things, same exact numbers on the numerators here. And basically what we've done whenever we said we can use any n we want to, is we basically said if we use the common denominator here, then everything has the same denominator, and we can basically ignore the piece size. We don't care how small those 30ths are. So we can just work with it as whole numbers, which is what we did up there. Okay. But the whole idea of the false position is, we don't care if we're wrong. We're just going to guess, and we're going to make it right, okay? So whenever I realized earlier, I'm not right, I've still got to go figure out what I'm missing, then I needed to figure out, okay, what did I multiply those other numbers by? It was a 30. So I need to multiply some other numbers by those same stuff and figure out where I'm headed. Okay, so that's kind of the point of false position. It's a little bit complicated sometimes, but it's doable. You're going to have a little bit of a homework question on that, so I wanted you to see that. Yeah, I really wanted to cover some geometry stuff with you, but I don't feel like I've got time to do geometry, so maybe I'll pick that up whenever I come back. I will say there's an interesting, while I'm on the idea of the Rhine papyrus, and doing all this stuff, geometry versus algebra. Let me say there is a different, so we'll come back to geometry because it's just going to take too long, but there's a different artifact called Plimpton 322. And this artifact, it's in your book. Where is it? Oh, goodness. It's starting section 2.5 in your book. Yeah. Starting around section 2.5, you'll see that it's a tablet, okay, and it talks about, oh, no, 2.6, that's where it is, page 72. I knew I'd find it if I just kept looking. So it actually talks about, it says it's a tablet concerning number triplets. So the number triplets are actually things that make up right triangles. Triplets. For instance, like the 3, 4, 5 right triangle. We know that guy, right? In fact, nowadays these triplets, we call them Pythagorean triplets, right? That's Pythagorean, who's a Greek who comes along later, okay? But he gets the credit because he wrote it down. But if you look at the Plimpton 322, that's actually a clay tablet, and it has stuff from the Babylonians on it. So it's interesting because even though it was the Babylonians, which is one of our earliest civilizations that we actually have a name for, they dealt with stuff with Pythagorean theorem, basically, is what it came down to. So you'll also see in this one some kind of cool stuff here. If you're not sure what this picture is, it's on page 75. This is a form of completing the square. Okay, so that is an algebraic thing that we do nowadays, and they were looking at that stuff back in the Babylonian times. So kind of interesting, kind of some cool stuff out there. I am running out of time on these videos, so I'm going to stop. And we'll just have to pick up Egyptian geometry and finish out. I really thought I'd finish out the Egyptians tonight, but I didn't. Sorry. I probably spent too much time on my soapbox at the beginning. So I think that we're not going to get that far. So instead, you're going to have these two homeworks I want you to look at. And it's page 51, number 4, 7, 11, 12, 14, and 15. I might actually assign that far on Friday in class, but I also want to add number 19, which is about false position. So take a look at that and make sure you're good on it. There's also some stuff on the Plimpton 322. I haven't really covered it. I don't want to spend a ton of time on it. It's Pythagorean theorem stuff. So what I'm going to do with that homework is I'm going to make it a little bonus homework. I know. Yay. So if you want to do it, you can. And if you don't want to do it, you don't have to. But it'll just count in as a free homework grade. It's not a lot of problems. 3, 5, and 6. It's on page 80. You'll have to read probably part of the book, but that's okay. It's a bonus. Okay, if you don't want to read part of the book, then don't. The problems are a little bit advanced, but I think you can do it if you just kind of think about it. So both of these, because this is going to be Monday's class, which is September 9, we'll make them do, 7 days after that is the 16th. Okay, so September 16th. That's it for this video. Thank you for listening, and I will see you on Wednesday for class. Thanks. Have a good night. Or day. Night while I'm recording this.